Got a request to do an allylic halogenation mechanism. And here it is. We're supposed to predict the major product and give an initiation and 2 propagation steps for the major product. Now, some students are looking at the iodine being on a tertiary carbon and saying, that's my guy. Yeah, it's tertiary allylic, which is has about the same stability as a 4.5 degree. But the other one, which is diallylic and secondary, remember, every time you're allylic, you add 1.5 degrees. So you do that twice, you got 3, add that to the 2, roughly 5 degrees stability. I'm liking this product. And don't stress out, people. If you pick the wrong product and gave me a perfect mechanism, you're going to lose 1 point. Not the end of the world. Okay. And we're supposed to do an initiation and 2 propagation steps. So here's init. Init's always the same. Oh, I always give you the side product here too. I forgot to do that. It's HI. If it lets me draw an I here. I just want to make sure that's on the original too. Yes, here we go. Here we go, HI. And now we start with our initiation. The heat breaks the weakest bond, and iodine is a very weak bond. It's one reason it's such a good antiseptic. It makes radicals and kills bacteria, just like this. Iodine radical. Prop 1, take your iodine radical, react it with the hydrogen of interest. Is this one? Oh boy, there we go. And generates a very stable diallylic radical. HI is formed, so that part of the mechanism's over. Stable diallylic radical also formed. And it's ready to do some magic. Oh, didn't grab the radical for it, huh?
Did you rotate the molecule?
I did indeed. He asked if I rotated the molecule, and my answer was, yes, I did indeed. It is the same molecule. Almost 100% sure, yes. Prop 2, that radical you made is going to react with the rest of the iodine, which you still have 100% of because you only reacted a few molecules for the initiation. You still have the remainder of I2, and they hook up. Both hookup mechanisms in the propagations look pretty much the same. Make sure both of these arrows start on the bond. I still see students starting one of those arrows at an atom where there's no electrons. The electrons are in the bond. Okay? And you're generating your other product and iodine radical. And this is where the majority of iodine radicals will be made and then used in Prop 1. And you make your product, which we circled already. And that's the end of that. That's all it asked for. So we got initiation, Prop 1, Prop 2. This be 6 points. It's not a big one. And that's all.